Okay, P1-18 for the 2014 and 2016 books. We're dealing with all circles, so we're going to have a whole pattern base circle that we're going to have to contend with since there isn't a center line circle, so to speak. We will end up having to convert those. We have our geometry in several places, so we'll probably end up with the circular pattern. So 6 holes and 60-degree increments. So first thing is we're in metric and we need to start to generate our geometry. Okay, in the front plane, pick up our sketch. And let's see, radius, our first radius is, our diameter is 100, so the radius will be around 50. You can kind of watch those numbers sometimes to get them close, but I'm really not that concerned about them. If I go ahead with the base circle, then I can also include the outer. Alright, so my smart dimensions, interior was 100, the exterior is 160, and with the circle it's going to go linear. We just pull out a little ways more, or we'll go linear on the inside, or diameter on the inside. So let's drag a little ways so I can get consistent. And then my base circle has a radius of 65.26. So this would be one of those cases where I would just go ahead and select whatever is given. And we want to switch over to the numbers. I'm going to switch to the liters. Okay, so this dimension is highlighted. And under the dimension property manager, then I'll come into the liters and we'll go from diameter over to radius. And then in its value, since we are handy, now that one's still showing as a diameter, so let's see what happens if we put the 65.26 in. And then hit enter. Okay, how about okay? Alright, so it did catch up and change from the diameter to the radius. Alright, so let's see, I am clear, I'm in my selection tool, and so I want to switch to construction geometry. So I can either highlight the circle and go to the context pop-up, or go to the for construction in the property manager. Alright, so the main thing with that center line is it's not going to participate in the creation of my objects. Alright, so we drag that out. We have a diameter of 15. Alright, and it doesn't really matter where we start. It's going to a symmetric pattern, so I do want to pre-select, and then the down arrow next to the linear is going to put me into the circular sketch pattern. We are going to a center point, so the point is at the origin, and for a circular pattern it will pretty much always point to the origin. And X dimension, Y dimension, 0 millimeters, and 0 millimeters will shift that pattern if we need it to. Alright, so I don't really want to dimension the radius. I drew the base circle. We could put that in. We could also put in the angular spacing, but I want to show you a couple things with it. So we'll go up to 6. 65.26 on the radius, and the initial angle being 0. There are no instances to skip, and even if there were, I would probably switch them over to construction circles so that I could modify them later. Alright, so with a circular pattern, since I didn't check those boxes, the pattern is free to move, and what isn't apparent is that you will get a center point for this pattern. For this instance, or for this sketch where we're doing the circles, it's not a big deal. But if I decided I wanted to do these holes with the hole wizard, that point from the hole wizard would show up as an instance even though it's in the center of the part. So on my drawing, I would do a hole call out that said there are 15 millimeter holes, and there are 7 of them even though we're showing 6. So that point is convenient in this case because I can drag it back to the origin, and that will allow me to go fully defined. And Control Z. So in the case of the hole wizard, I want to delete, and then we're going to pick any one of those center points and make it coincident to my base circle. Alright, so then we're a little bit closer. The other thing I can do is just grab a center point. When I drag it back and it finds coincidence, that's going to give me my coincident relation back to the base circle. So as I mentioned, if I decided that I didn't really want to include these in the mix, I can switch these over to for construction. The other thing is with our contours and regions, this is a successfully nested. There are no doubly nested. Well, there are, but let's see under the sketch what the shaded contour shows. So it shows the one level and the interior. All right, but there's nothing crossing that's going to force this into a contour and region situation. So in that case, our thickness is 20 millimeters, and if I accept it, it will include all of the holes. Well, if I go back and say, no, I really didn't want to do that, and select the contours, that's going to make a full cylinder, and when I come to the interior contour, that is going to make it a donut, pretty much ignoring the holes that I included in the sketch. Alright, so I can manipulate this. 99% of the time I put those circles in there, I'm going to stay with them, and they're going to show up in this first feature. Alright, so for your project, if you just accept it and the holes show up, I'm going to be fine with that. I want to illustrate the hole wizard or introduce the hole wizard. So I can hit the S key, and the hole wizard will show up on the S key. That's my usual preferred method of navigating to it. We can always go up to the command manager, and I am going to pre-select the face so that it knows what 2D planar surface I'm going to be sketching on. Alright, so we go into the hole wizard, and this is a fairly extensive database. We're going to look at different styles of counterbores, of hole. So the advantage of the hole wizard is right now these are through clearance holes for maybe a 12 millimeter bolt. And we decide that I need to have a little relief and go to the counterbore, or I need to make the mating flange, which is going to be threaded. I can switch those out a lot easier and have a lot more data, industry standard specifications for the counterbores, for the countersinks, a standard hole, a threaded hole, even going so far as the tapered pipe taps. All right. So then we'll get into the rest of these as we go. So this is an ANSI metric. We have quite a few available in the way of standards. This is going to be a bottoming tap. Oh, am I in tap? Apparently I moved to tap. Well, make sure that the hole type is selected, that we're in ANSI metric. I do not care about dowel holes. I just want the drill sizes. So dowel holes are a little bit different in that they're going to give us a tolerance zone. Is this the slip side of the dowel or the press side of the dowel? All right, so we can manage dowel geometry. So we go into the drill sizes and then pick, and it's going to be down here a little ways because we're going in pretty much 0.1 increments until we get to the larger sizes. And then we're at 15 millimeters, and it has an up to next in condition. And then if you wanted to include a near side and far side countersink, so would 0.05 millimeters, that's not really a lot. If we did half a millimeter, that would be basically 10 thousandths converting back to inches, that would be 10 thousandths per side. And then a 90-degree or whatever angle we wanted to include. So the diameter of the countersink to the outside. Most of the time, I'm going to recommend that you call out an edge break somewhere on the print rather than including the chamfers unless they're necessary. Alright, so for our location, I don't see anything over here asking me for a 3D sketch, so that makes me happy that I'm not seeing that one. I want to just go in. If I did get a 3D sketch, I would just select on that face, but since I pre-selected and I'm automatically in that 2D sketch, then I'm just looking for a location. Alright, so we come back, we're going to do the same types of things. We'll go in and make horizontal, so that gives us a location. And this time without the base circle, also as a contrast is a circular sketch pattern. There are going to be 6, and the radius was 65.26. And I'm going to have it dimension the radius and the angular spacing. Okay, 60 degrees angular spacing, so we'll get that value in there. No instances to skip. Let's go ahead and see what we get. Alright, so still didn't quite go fully defined. And with the center lines, I don't quite see it. Let's see if it's there. Alright, so that would be a preference to getting that 7th location. Alright, so what I can do in this case is the intersection of those two center lines, drag that back, and that's going to define my point. Alright, we'll save this. And then I want to verify that what I've just told it to do is working, because I'm still concerned that those center points can show up in my hole count. So we're going to make drawing from part, let it pick up standard drawing. Alright, so if we did the whole table and it came up with this, if the only show standard formats is on, and you were to pick an ISO A0, then A0 is the largest size, A4 then is, well, that one looks portrait. Okay, not sure what's quite going on with those, so we'll go back to the standard formats, stay with the standard ANSI landscape, and then we'll build our own template here at some point. Alright, so it brings it in, it puts me in the view palette. If it comes up with something different, mainly the view layout, model view, will look more like this. That's what we, kind of the default. And then these are the views that we would want. I think industry is kind of moving towards the view palette, so we'll just stay with that. And because my center lines and marks are on, then I'm going to have those show up in their values. Alright, so I'm not going to fully dimension this out. I'm just looking for the annotation for the whole callout, and we'll pick a location, and that's showing 6 at 0.59. Alright, since we're in inches. Alright, so if I saw 7 there, and I know that I have 6 holes that are the 15 millimeter, then I'm going to go back and look for that 7th center point to be the culprit.